Alright, in this lesson we're going to take a look at some basic acid names, and there's a systematic approach for these. There's a lot of different ways to name acids, and sometimes there's some older ways they're named and some newer ways that they're named, but there's one general structure that if you get down, it's easy to go between those names and sort of see a logic to it. So it all starts with the ion name. When I say ion, I mean what's attached to the hydrogen. Okay? So what you want to do is you kind of want to start with 8. 8 is a really common thing, like sulfate, nitrate, phosphate. Those are the things you want to memorize. You want to memorize and figure out what all the 8 forms of ions you have, what they look like, what their formula is. Now, if I know that something, pretend I have good handwriting. Here, let's change that up a little bit. Oops. Okay, so make sure I'm neat enough for you to follow. Okay. So if you have anything that ends in 8, like nitrate, sulfate, phosphate, if that's what's attached to the hydrogen, no matter how many hydrogens happen to go with it, then this acid is an ic acid. Okay. So like sulfate becomes sulfuric acid. Phosphate becomes phosphoric acid. That's what's attached to the hydrogen. Okay, now once you know that, everything kind of stems from that spot. If I happen to find something that is an ite ion, so let's say it's hydrogen nitrite or hydrogen sulfite instead of sulfate, ite becomes an us acid, and these are the two most common ones when you're dealing with polyatomic ions. So for example, sulfite would become sulfurous acid. Okay, now we get to some weird ones. These ones don't show up quite as often. If I have hypoite, okay, like hypochlorite, then this becomes a us acid, hypochlorous. Okay. If I have something like per 8, that becomes a per ic acid. And I'll show you some examples of those. Now the reason I put it in this order is this order usually, those words aren't just there by accident. Those endings kind of tell you how many oxygens are combined with whatever that other ion is. Okay, and that goes back to your naming system for polyatomic ions. If you kind of memorize the 8 form, everything sort of comes from that. You can recognize all of these. Now let me give you some examples of this. There's one other type that you got to watch out for, and this does happen quite often. It's very commonly misunderstood. If you have an ide ion, like hydrogen chloride, hydrogen sulfide, hydrogen nitride, then if that's what the ion ends in, that name, then this becomes hydroic, hydrochloric, hydrosulfuric, hydronitric. It depends on what it's with. So these are the different kind of acids you can get. If you know the chemical name, which is over here on this side, then you can make up the acid name. Okay, we don't usually name the hydrogen because hydrogen goes with every acid, so there's no sense in saying it. Now let's take a look at some examples. Okay. If I were to see HClO3, I would want to figure out the chemical name for that. And the chemical name for this is hydrogen chlorate. This is the chlorate ion. So this becomes, since it's an 8, it becomes an ic acid. This is chloric acid. So what's that going to look like if I had HClO2? Now that's chlorite, so that's going to become chlorous acid. Okay, they mean something different. It's the amount of oxygens that happen to be in that ion. Now what if I just have HCl? That's hydrogen chloride, which is going to make it hydrochloric acid. Hydro only comes in when you have a single element with the hydrogen and it ends in "ide." Hydrochloric acid. So there's a few examples of that. If you just jump in and figure out this part of it, that tells you what the ending should look like.